Hello and welcome to another YouTube tutorial session today with E2 tutorial. So excited to be with you all today again and have to learn some statistical analysis with R. Today's session would look at inferences about population variance, but before we start the session, please make sure you like and subscribe if you're not following our channel, and also leave whatever comments you have as you watch the video, and please make sure you're practicing along with your R Studio as you watch this video. Just wanted to put that out there before we go ahead and start looking at some of the things we have for you all today on this video. I have my R opened up already. I will share this this Canvas file in the YouTube description. So if you want to learn more, you can always just open up the file, see the problem statement for what we'll be discussing today. All right, today's topic is inferences about population variance, and we're hovering around the concept or the topic or the term variation. And variation just basically means something that varies, right? As simple as that. So everything around us in the world today or our environment, you would see variation, right? Basically objects or items that basically varies. We as humans, we vary, right? I might like something, another person might not, right? So that's basically variation. And when you look at this picture I have here, you could say maybe some frogs or some toads, but this is 6 of them, and you can see the variation that is there between each of the frogs, right? Maybe some have a wider feet or smaller feet or longer arm or short arm, right? The color of their skin or their body is completely different between each of these frogs. So that's just variation, right? So now back to statistics, right? So inferences of the population variance, it just basically involves us using sample data to estimate or test claims about the variability, right? Or I can say spread of a single population. So that's a simple and easy on what variation means. Now let's look at a problem statement and try to solve all of this. Try to solve this problem using statistical analysis, and we'll do this on R Studio today. The competitive advantage of small American factories, such as tolerance contract manufacturing, lies in the ability to produce parts with highly narrow requirements or tolerances that are typical in the aerospace industry, right? The specifications and tolerance in the aerospace industry, it's something else, right? It must meet a particular specification or tolerance, unless it wouldn't be installed into an airplane, right? Because of how delicate and sensitive an aircraft is. Now, consider a product with specifications that call for maximum variance in the length of the parts of 0.004. Suppose the sample variance for 30 parts turns out to be 0.005. We're given our alpha as 0.05 to test whether the population variance specification is being violated, right? So we'll in a minute would get to transition, or in some seconds would get to transition into R, and we'll try to solve this problem using R. So let's solve it. Let's get to work. All right, so I have my R Studio open up, and the first thing I want to do here is just all right, so I'm just kind of calling it an aerospace part manufacturing problem. All right. And from the question, the very first thing I like to do is to develop the null and alternate hypothesis, because that would give us an idea of what we're testing, and also what type of test statistics we would use for this analysis. So All right, so now we have the null and alternate hypothesis written. So let's go back to our question. So we're being asked, you can see it down here, to test whether the population variance specification is being violated, right? And that specification is 0.004, right? That's basically the specification that is given in the aerospace industry. So we basically want to see if the parts that have been produced, that's the 30 parts that have been produced, do they exceed that specification or not, right? So with that, we can set up our null and alternate. So HO would be population variance is less than or equal to 0.0004. So this is a one population variance hypothesis testing, right? So that's why we only have population variance. So we're just dealing with one population. And then HA, so this has to be a comment. I forgot to put that. So population variance. So we want to see if it exceeds 0.04. All right. So I think that is yeah. So maybe I could say that we could just say variance. So we could just say variance in the length of the parts. So yeah, that's basically it. So we can define our population parameter as the variance in the length of the parts. Now that we have that done, step 2, we could kind of list out the parameters that we're given. And one of those parameters is our population variance, which is 0.004. The second one is our sample variance, which was given as 0.005. The next one is our sample size, which is 30, right? So I'm just going to put some stuff here so you know what they mean. So population variance, this is sample variance, and then this is sample size. All right, so we have that there. Our step 3 is to compute the test statistics. And because we're dealing with variance, we use the chi-squared test, right? That's basically what we use here. So this is going to be our equation. So, so we multiply this by the sample variance, then divided by the population variance. So, so that's the equation we used for our chi-square test. All right, so now I would basically just run the code from line number 9 all the way to 15. Right, so please make sure you run your code as well. So run. Okay, so our chi-square, the result for our chi-square test is 36.25. I'll just put it by the side there, 36.25. Now, step 4 is to compute our p-value. And we do this using the chi-square p-value function, which is just called p chi-square, right? So that's the function we use. Now, in order to determine what equation we would use for the p-value, right, you need to take note of something. Because this is a greater than, that means it's an upper tail test and it's one-sided, right? It's a one-sided upper tail test. So we have to make sure that we use the equation that basically reflects this equality sign, right? So for our p-value, so I like to round my answers to 2 decimal places. So I'm using the round function so that make sure that my p-value is rounded to 2 decimal places. And then we use the function to get the p-value, which is the p chi-square. And then we have our test statistics. We have to bring in test statistics there. And it has a degree of freedom, which is n minus 1. And then to lower the tail, we have it as false. So because this is greater than, you would set the lower tail as false. If this here was less than, right? If, you know what, if this was less than, right, that means this would be this, right? If it was less than here, what you would have here would be true, right? Please take note of that. If your hypothesis, your alternate was less than, then your lower the tail will be true, right? So because it is greater than, right, our lower the tail is false, in like taking into consideration that this is an upper tail test. Now, if this was two-tailed, meaning that you had this and this, right? All you would just do is we would have 2 multiplied, right? That's basically all we would do. We'd multiply this whole thing by 2. So I just remembered I need to put the round decimal place there. So if this was two-tailed, you would just basically multiply everything by 2. But since this is not two-tailed, we're not multiplying it by 2. So I'll take that out and I'll make this less than, and then this should be greater than or equal to. So please do take note of that. And this. All right. So let's run this. So now you can see our test statistics is here. Our p-value is 0.17, right? And if you remember from the question, we're given alpha as 0.05, right? So now let's come up with our business interpretation. So we know that the p-value, which is 0.17, is greater than alpha, which is 0.05, right? So our first conclusion would be do not reject HO. And when we say do not reject HO, what we're saying is that this one is true and this is false, right? Now, or we'll just add the product specification. Does not appear to be violated, right? So, no, sorry, I put the wrong sign there. This should be, yeah, less than or equal to. So what we're saying is that the product specification does not appear to be violated, because when you look at our, so first of all, the p-value was 0.17, which is greater than alpha, right? So you say do not reject HO. And then when you come to your null and alternate hypothesis, we can basically see that the null is true, right? Anytime you say do not reject HO, that means the null is true and the alternate is false, right? And in this case, based on our analysis, the product specification does not appear to be violated because the population variance is less than 0.004. So please do take note of that. Try to solve some more problems and get yourself acquainted or comfortable or familiarize yourself with how to use R for statistical analysis. Once again, please remember to like and subscribe to this video, and I hope this was helpful to you all. Thank you.